Alright, so for this one, Properties of Exponents Everything, first thing I want to address is, let's write some notes at the top here. Students always are confused, or usually they're unsure when they're finished. Okay, so I want you to write this. You are done when. Okay, there are three things to look out for. Okay, you are done when. The first one is you have no negative exponents. Okay, you have no negative exponents. Okay, the second thing is there's only one of each variable. One of each variable. Okay, so if you see an x and then another x, you're not done. Okay, if you see an x and then another y, that's the only other y, then you're done. Okay, so one x and one y. Okay, there can't be two or more any variable. Right, and then the third thing you need to look out for is the coefficients. So the big numbers, the big base numbers with exponent of 1, okay, the coefficients are simplified. Okay, so if those things are checked off, all three of those, you have all three of those things, then you're finished. Alright, so let's take a look at number 1. Alright, so number 1, first thing, hey, no negative exponents. We have a negative exponent there. Okay, that negative 2. So we're going to go ahead and we know when we have a negative exponent, we're going to rewrite it as a fraction. So I want to rewrite it as a fraction. That x to the negative 2, that's going to go to the bottom. X to the positive 2. Okay. So I'm going to go ahead and just cross that out, but just leave it so you can still see it. Okay, so that's kind of crossed out there. Now what's left here, there's still a 5 to the 1 power left. Okay, so if you want, that 5 doesn't have an exponent. I should probably have done that first. That 5 has an exponent of 1. Okay, so there's a 5 to the 1 and then a y to the 7th. Okay, and then there's only one of each variable. There's a y, there's no other y, there's an x squared, there's no other x, and the coefficients are simplified. That means this 5, right, it doesn't need to be multiplied or divided by any other number. Okay, so we're done here. All these are checks. Okay, we've checked off all three. So if I want to rewrite it without the 1 on the 5, because 5 to the 1 is just 5. So I want to rewrite that, right, 5y to the 7 over x squared. Okay, that's how I would rewrite it. Alright, so again, anytime you see a negative exponent, you're going to rewrite it as a fraction. Okay, so let's go ahead and look at this one. Hey, this one I have another negative exponent. Okay, so, actually, sorry. There were some that Alright, so this one has a negative exponent. Okay, so I'm going to rewrite this as a fraction. Okay, I'm going to make my fraction. Alright, so everything has an exponent on it. This 8 to the 0, that'll stay, it doesn't have a negative exponent. This 7 to the negative 2, well, that's going to be a 7 to the positive 2. Okay. Alright, let's simplify some of these. Okay. Alright, so 8 to the 0, I know anything to the 0 power is 1. Okay, 8 to the 0 is 1. So the 1 stays in the numerator. Alright, 7 squared, well that's 7 times 7. 7 times 7 is 49. This is 1 over 49. Okay. Alright, so let's double check. No negative exponents. There's only one of each variable. Well, there aren't any variables here. Okay. And the coefficients are simplified. 1 over 49. That fraction is already simplified. Okay. Let's take a look at another one. Number 3. Alright, let's go ahead and write in exponents for anything that doesn't have an exponent on it. This 6 does not have an exponent on it. I'm going to write a 6 to the 1. This 5 doesn't have an exponent on it. I'm going to write 5 to the 1. Neither does this x. It has a 1 exponent on it. Okay, alright, so all those things have a 1 exponent. The 6, the 5, and the x. Alright, so let's go ahead. Well, the 6 and the 5, they both have 1 exponents. Okay, so that's a regular 6 and that's a regular 5. We're multiplying. So those regular numbers in a multiplication, we're just going to multiply them. 6 times 5 is 30. Okay. The x's. This x has a 4 on it, and this x has a 1 on it. Okay, so multiplying, so we're going to add those exponents. 4 plus 1 is 5. Okay, so the x, 4 plus 1 is 5. And then the y's, let's see, there's only one y, this y to the 8th. So that just comes down. It just stays y to the 8th. Okay. And that's all I can do. There's no negative exponents. There's only one of each variable. The coefficients are simplified. There's only this 30, right? I already simplified the 6 and the 5 together to get that 30. Alright, so the next one, number 4, this is a y on here. Make that a y. Okay, so let's go ahead and there is a negative exponent here. I'm going to take care of that in a second. But let's go ahead and write in exponents on the 3 and the 9. The 3 and the 9 both have both have 1 exponents on it. Okay, this is a regular multiplication problem, so I'm going to multiply the 3 and the 9 together. 3 times 9 is 27. So I have 27 y to the negative 7 x to the 5. Alright, so now after I've multiplied those together, what I'm going to do now is take care of this negative. Okay, so I'm going to rewrite it as a fraction. That y to the negative 7, that's going to go to the bottom. Y to the positive 7. This 27 here has a 1 exponent on it, so that's just a 27. Okay, so the 27 has a positive exponent, so does the x. Okay, so 27 will stay in the numerator, 27, and then x to the 5. Okay, and this is the simplified form. Okay, so why didn't I, if you're asking why didn't I write the 1 on the 27? Well, 27 to the 1 power, what's that? That's just 27. So I just left it as 27. Okay, I think I'm going to do the first 10 with you. Right, so we're on number 5 now. Alright, so number 5, hey, this is a division problem. Alright, the bases are the same, x. So since the bases are the same, I'm going to subtract. Okay, so this is a 12 minus 4. 12 minus 4 is 8. So this is just x to the 8th power. Okay. The next one, alright, so the next one, the bases again are the same. They're both 4, and it's a division problem. So I'm going to subtract these exponents. This is 12 minus 15. 12 minus 15, the order matters. Okay, so this is a negative 3. So this is a 4 to the negative 3 power. It's a negative 3 exponent, so I have to rewrite it as a fraction. So 1 goes in the numerator. 4 to the negative 3 becomes 4 to the positive 3 in the denominator. Okay. Alright, so 4 to the positive 3, well, I know that's 4 times 4 times 4. You can do that in your calculator. Okay, 4 times 4 is 16. 16 times 4 is 64. So 1 over, and then 4 to the positive 3 is 64. Alright, so the next one, this is a power being taken to another power. Okay, you don't have same bases here. This 3 doesn't have a base. This, right? So it's not a case like in number 3 where you would add the exponents. Okay, this base x has a 1 exponent. This base x has a 4 exponent. I would add the 4 and the 1 together, and I get x5. This one, there's only one base. Okay, one base of x. Okay. It's this negative 8 taken to the 3rd power, so this is negative 8 times 3. Negative 8 times 3 is negative 24. Okay, that's a negative 8 times 3, and that's a negative 24. So this is x to the negative 24 power. Okay, so you times those. Alright, now negative exponent. I'm going to rewrite it as a fraction then. 1 goes in the numerator. X to the positive 24 goes in the denominator. Alright, so take a look at number 8. Anything that doesn't have an exponent, write an exponent of 1 on it. This 5 has an exponent of 1. So does this x has an exponent of 1. So does this 6 has an exponent of 1. Okay, the 5 has an exponent of 1. The x and the 6 also. Alright, so all of those are being taken to another power of 2. So I'm going to multiply the 2 into those other exponents. Okay, so for the 5, the exponent is 1. 1 times 2 is 2. For the x, the exponent is 1. 1 times 2 is 2. And then for the 6, the exponent is 1. So 1 times 2 is 2. Okay, anything that doesn't have an exponent, write an exponent of 1, and then you got to multiply that 2 in. Okay, because all those exponents of 1 are being taken to another power of 2. Alright, so now I just have to simplify. 5 squared, that's 5 times 5. That's 25. And then x squared. This 6 squared, this is 6 times 6. So this is 36. Okay. Alright, let's do numbers 9 and 10. Last two. Alright, so for number 9 and 10, anything that doesn't have an exponent, let's write an exponent of 1 on it. This 4 has an exponent of 1, and so does this x has an exponent of 1. The y already has an exponent of 5. So I'm going to multiply the 2 in to all those other exponents. So for the 4, okay, 1 times 2 for that 4, that's 2. For the x, 1 times 2 is 2. And for the y, 5 times 2 is 10. Okay. Alright, now I just have to simplify this coefficient. This is 4 squared. Okay, 4 squared is 16. And then x squared, y to the 10th. Okay, and then the last one, number 10. Anything that doesn't have an exponent, let's write an exponent of 1 on it. The 7 has an exponent of 1 on it. I'm going to write an exponent of 1 on that 7. I'm going to multiply this negative 2 in. I'm multiplying that negative 2 in. So for the 7, 1 times negative 2 is negative 2. For the x, negative 2 times negative 2 is positive 4. And for the y, 3 times negative 2 is negative 6. Okay, so notice I have some negative exponents now when I multiplied. So I'm going to rewrite this as a fraction. That's 7 to the negative 2, that goes to the bottom, becomes 7 to the positive 2. This y to the negative 6 goes to the bottom and becomes y to the positive 6. The x to the 4, that'll stay in the numerator. Okay. And so let's go ahead and look at our checklist here. So our checklist, no negative exponents. We don't have any negative exponents. There's only one of each variable. There's an x to the 4th, y to the 6th. Coefficients are simplified. So we just need to simplify this coefficient of 7 here. 7 squared. Okay, so let's go. That's 7 times 7. Okay, so that's 49. So my final answer is going to be x to the 4th in the numerator. 7 times 7 is 49. And then I have this y to the 6th also down there. Okay, there's my answer.